bell ringer for the day. It says, find 2 points that lie on a line that have a rate of change of 6. Okay? I gave you the formula that you will use to find the rate of change, and I gave you the answer that you should find once you choose what order pairs you would have to use. All right, so this is what the question is asking us. What we have to do is we have to pick points. I only saw pretty much like 1 or 2 of you doing that, so let's just pick some points. I know this first point is going to be x1. I know the second point is going to be y1. I know this second x is my x2, and this second y is my y2. That means that I'm going to put it into this formula, the numbers that I get to choose. So like I haven't done this problem yet either, so I am quite literally doing it for the first time. So let's do 1, 2, and then because it's y2 minus y1, this number has to subtract to 2, and I have to get 6 on top. So let's put 8, and then 2 minus 1. So now we have our 2 order pairs, 1, 2, and 2, 8. So let's go ahead and replace the y2 with the value of y2, which is 8. Now I'm going to replace my y1 with the value of y1, which is 2. And then I'm going to replace my x2 with the value of x2 that I found, which is 2. And the last one, x1, is 1. So 8 minus 2 is 6. 2 minus 1 is 1. That would be an average rate of change of 6 over 1. So go ahead and write that out. Finding 2 ordered pairs that are much like those, you'd have to have 6 on top. Change of y on top is 6. Change over x of x is 1 on the bottom. So 6 over 1. Did anybody else come up with something different? All right. So today I'll be going home and grading your Khan Academy assignment. All right. I didn't get a chance to do it last night, but it closed this morning. So I'll make sure and get through them today. Once you get done copying that, make sure you're writing your agenda. It's week 29, day 1. We're doing a mini review on CED.1.1. That should go back into your folder. Make sure that bell ringer makes it right behind your agenda in your notebook. And then all we should have out now is our yellow notes. Welcome to Coastal. Make sure you sanitize your hands. Take out your yellow notes that say review of CED.1.1. Review of CED.1.1, which it means create equations and inequalities in one variable and use them to solve problems. And that's what we're going to be doing today. These questions that we are about to go through are the hardest that you are going to see on the EOC. We have 20 days of review. We are going to be reviewing it up for the next 20 school days. All right, so make sure all you have out is your review of CED.1.1. The blue papers that you grabbed on the way in are your skill builders for the week. If you are at home and a live student, the skill builders were posted on Canvas also. If you lose your blue copy, you can always go to Canvas, week 29, skill builders, and then click on it. So let's begin for the day. This is your standard. All right, sorry, standard right here. Create equations and inequalities in one variable and use them to solve problems. So on your EOC, you're going to be asked to do these type of problems, but you're going to have drag and drop.
We have Lauren Carney and Matthew Schultz.
I have both.
They just tell them to give those to their parents and the survey.
Yes, sir. Thank you. All right, so the type of questions are going to be asked on your EOC. You have drag and drop response. All right, hotspot response, multiple choice responses, open response, open prose. Number 2, items may include equations from linear or quadratic functions, a simple, rational, absolute, or exponential function. Items may require students to rearrange formulas. Items may require students to recognize equivalent expressions, okay? So let's go over our first problem. Let's all open up that yellow packet. We're going to do this first problem together. We're going to do all these problems together. So I have done these problems, but I have lost the work. So as I am talking, you're going to hear me doing what they call a speak aloud or talk aloud of what I would literally say in my head if I was doing these problems. They're not easy, but if we can get through the hard problems, the easier ones are not going to be that difficult, all right? So a parking garage charges a base rate of $3.50 for up to 2 hours, an hourly rate for each additional hour. The sign below gives the prices for up to 5 hours of parking. Now, before we read the rest, if we're just looking at the parking rates, is there something that you can see that may stick out? We haven't even been asked what to do yet with this problem, but you got your hand out? The yellow one? Let's pull it out. So what, if we just look at those numbers inside of the parking rates, is there something that we can determine? Okay, they go up by 1 hour. I'm cool with that. What about the money? There's something with the money. Is it the same amount in between each one? What's the difference between the first and the second? Huh? So between hour 2 and hour 3, there's a difference of $5.50. What about between $9 and $14.50? What's the difference there? $5.50. Okay. And then between $14.50 and $20. $5.50. Okay, so there is a little bit of a pattern there. All right. That is the change in the parking rates per hour. It looks like it's consistent, so that looks like there's a common difference. So this problem is pretty wicked because it doesn't say write the equation for the parking rate. The question says, what linear equation can be used to find x, the additional hourly parking rate? So what are they asking us to do with each one of these problems if they're saying, no, he's not, sir. No, sir. Okay, so when they say use to find x, they want you to solve for x. So let's go ahead and try to solve the first problem for x. All right, so I have 9 plus 3x is equal to 20. What would I move first here? 9, so let's subtract 9 from both. Okay, I'm left with just 3x. 20 minus 9 is 11. Okay, so what's, I divide by 3 by both sides. So what's 11 divided by 3? Somebody give me that. We'll do B right here, just in case. What's 11 divided by 3? You can use your phones if you want. So here's the deal. Either we work through these problems together, or I just give you your computer work, and you can just review on your computer for the rest of the year, whichever one you guys want. But I need participation, okay? 3.6, okay? So that means that when I solve for x for this first problem, it's 3.6. So we're going to write 3.6 right there. How do I solve for x up here? Same thing. I subtract 9. Yeah, tomorrow we'll probably just start on computer work. Okay, so I'm left with 350x. So 20 minus 9 is 11 again. I have to divide both sides by 350. Ha 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 ha, it's disappearing. So what's 11 divided by 350? 0.318. Okay, so 0.318. All right, so that must be 30 cents. Let's do C. We're going to put it right here. 2x plus 350. I'm just solving for x for each one of these problems to get the answer. So what am I going to move here? Yep. So if I subtract 350 from both sides, I'm left with 2x on the left. And then 1450 minus 350 is 11. So we divide by 2 by both sides. We divide by 2 by both sides. So what's x equal to with that one? Very good, $5.50. So if I go back, I can write that one right here. And let's do this last one on the right side. 2x plus 9 is equal to 1450. So what would I move on that equation? The 9, so I'm going to subtract 9 from both sides. 2x on the left is equal to, what's 1450 minus 9? 550. What's, to get the x by itself, I have to divide by 2 by both sides. So what's 550 divided by 2? 2 what? 2.75. So these are our three answers. We have A, which is $3.60. We have B that came out to 38 cents. We had C that came out to $5.50. And D that came out to $2.75. So which one looks as if it gives you what X is, the additional hourly parking rate? C, because it matches the difference in the box. Each one of these was $5.50 different. So your first answer will be C. C. You got the same answer? It's okay. Sometimes there's different ways to do things. Give me about 15 minutes, and I'm going to give you guys 2 problems to do. I'll check your workout. Okay? So let's try this one. Okay? I'm going to do the third one because the second one, let's flip over the page. Let's go to the third problem. Okay? Welcome first. Make sure you sanitize your hands. So we're going to do that, the one that starts talking about Chiron last. Let's do this problem. John has a goal to ride his bike at least 100 miles this summer. John has ridden 12 miles thus far. There are 40 days left in the summer. Okay? You have to write an inequality. Inequalities get a little bit tricky because you have to remember what the symbols are. All right? So, greater than, less than, greater than or equal to, less than or equal to. So let's write an inequality represent the average distance in miles John must ride each day for the rest of the summer. So how many days does he have left in the summer? Okay, so he has 40 days left. And how many miles has he already ran? Okay, or he rode his bike, excuse me. So, John has ridden 12 miles this further, 40 days left in the summer. So that's how much he started with. He wants to at least run, he has 40 days left. Oh, okay, I got it. So let's erase this equation symbol, because what are we trying to write an equation for? The miles that he has to run. All right, so we have 40, which is the days, 12, which is the miles that he's already gone. All right, so I know I can plus 12 there. Where am I going to put my variable? Do I put my variable with the 40 days that are left or the miles that have been run? So let's try. If I put that D there, all right, we have to solve. So if I'd be subtracting 40. What is this 40 in relation to? The days. So I'd be subtracting days from the miles. So let's go ahead and rewrite it just slightly. Okay. So instead of subtracting 40, I'm going to put the days with the 40. Now, let's find our answer. I'm going to subtract 12 from both sides because that's the miles that he's already gone. What's 100 minus 12? Okay, so 88. And now I have 40 times D is equal to 88. So I want to find, I'll get the D by itself. So what do I have to do to get that D by itself? Divide. So let's divide both sides by 40. I divide both sides by 40. What do I get? What's 88 divided by 40? 2.2. Enter your inequality. Ooh, I used an equation symbol. So let's change that. So he wants to achieve his goal of 100 miles this summer. Does it say that he wants to run above 100 miles? No. So he wants to run less than, greater than or equal to. Let's just do greater than or equal to. That works. I apologize. Greater than or equal to. Okay, so we subtracted 12. We divided by 40, and you got 2.2. So what does that mean? If D is equal to 2.2, what does D represent? Very good. How many miles he has to do daily? So the inequality that we would write would be 40 times D plus 12. Got to be greater than or equal to 100. And sorry, we just found out the second part. D is equal to 2.2 because we already solved. When you get done copying, flip on over to the next problem. And I would like for you to, if you're already done, attempt to start it real quick. But we're going to go through these last two problems, and you're going to have about 10 or 15 minutes to practice a couple problems. And you're going to use these notes to be able to do so. All right, so a school purchases boxes of candy bars. All right. Each box contains 50 candy bars. All right, so literally I would put one box equals 50 bars. I know it already says that in the word problem, but this is just how I do my work. One box equals 50 bars. Let's see what else I said. Each box contains 50 bars. Okay, we got that. Each box costs $30. So one box, 30 bucks. Okay, so how much does the school have to charge for each candy bar to make a profit of $10 per box? Okay, so the boxes cost how much? How much do they want to make per box? So if we added that to the amount that we get charged, we would have what? $40 per box, because then we would be making $10 per box. All right, so how much does the school have to charge for each candy bar to profit? Ooh, that's not good. What they want us to do is, so 50 bars per box. All right, so what do we have to charge each candy bar to make $10? So what I would do is, let's write an equation. All right, so 40x is equal to the 50 candy bars. So this is the cost of the box. How many boxes do we have to charge? Candy bars. So how many candy bars do we have to charge? So this is something that I had to fool around with to see if I could get one of the answers in the answer choices. So let me pull up a calculator real quick. So let's do a little bit of dividing. If I wanted to, that's not what I wanted, pardonnez-moi. Let's solve that equation and see what happens. So 40x is equal to 50. So to get the x by itself, I have to divide by 40. Divide by 40. All right, so 50 divided by 40 is what? 50 divided by 40. 1.25. That is one of the answers. So let's just pencil that for a second, okay? Now let's try another equation. Each box contains 50 candy bars. Each box costs $30. So let's do $30. 50 bars. Let's do 50x is equal to the $40 that we would make per each box. So I would divide again. Divide again. What is 40 divided by 50? 0.8. Okay, so let's see. 40 divided by 50, 0.8. Okay, so I would say those are my two answer choices. We got 0.8 for this one. We got 1.25 for this one. Okay, so the top one, we had our variable beside the cost of the box of candy. Okay, on the bottom, we had the variable beside how many candy bars we had per box. All right, so I would say that, boom, 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 we have to sell it at 8 cents per box because the variable isn't going to be beside the amount per box. It's going to be beside, you put it beside the amount of candy bars you sell. See. And I guess what I'm going to do is get the work that I gave Miss P. Give you all some extension problems. Pull this up. Let's see if I can change this real quick. So I'm gonna put a problem up on the board and I want all of you guys to attempt it. There's only so many ways to get these problems done, guys. Like it's either we work on them together and I feel as if, yeah, this is gonna be what the next 20 days are. So I'm gonna talk to my math coach to see what we could do better. Just let me get rid of these problem answers real quick and we're gonna see what. So on the back side of that yellow sheet, I don't want you to write the problem, but I want all of you to read this problem really quickly. I want you to attempt it. If no, actually, give me one second. I'll put it up on a PowerPoint. For some reason, it's being a little temperamental. Okay. So, boom, boom, boom. Bear with me. Thank you for being patient. Okay. Let's do these last problems. 1, 2, 3. All right, so let's attempt this problem for the next like 4 or 5 minutes to see how we do. All right, so we are writing equations or inequalities, and then we're in one variable, and we're using those equations or inequalities to solve for that variable. So I'll read the question. I want you guys to attempt this. You're going to write an equation out. So there are 60 students going to the field trip to the chocolate factory. The students are from 3 different classes. Ms. Hooper's class has 24 students. Mr. Gomez's class has 18 students. Which of the inequalities describes the students that could be used to solve how many students? Well, we're not going to, I want you to try to attempt what inequality you would write here, okay? So you have 3 different teachers. They didn't give you Mr. Anderson, they gave you the other 2, okay? So I don't want to give you the answers because they already had them highlighted. So what information can I write out to the side before I start to try to write this equation? So there's over 60 students, okay? So Hooper has 24, and then Gomez has 18. And then we had a teacher that we don't know how much is, which is Anderson, okay? So they want us to write an inequality. So our inequality symbols are greater than, less than, greater than or equal to, or less than or equal to. And so how many overall students do we have? 60. Can we have more than 60? Can we have less than 60? We Okay, let me see. So because we're writing in an inequality, we can have less than 60 or equal to it. Okay, so what else can I do to continue writing this problem out? How would I set up this side, the left side of this inequality? Very good. We can add the other two teachers. Okay, so the one teacher had 24 students, so 24. And then another teacher had what? 18. And is that 3 students? 3 classes or just 2 classes? 2. So what would the last thing be? The last part says let A represent the number of students in Mr. So what would I do to represent Mr. Anderson's class? Yeah, would I add A? I would add A. So all of those. And actually, I was incorrect. We're going to make this equal sign because it does have to equal 60. We just wrote the equation for Mr. Anderson's class. I know this is pretty dry, guys. I know. Trust me, I know. Here's another problem that I would like for us to try. Let's write another equation out, please. I'll put this on the board. Well, what we can do is I'll put it on the PowerPoint. All will be placed on the PowerPoint. Keep going. 2 more. 20 minutes left. Okay. Let's just get rid of all of this. We'll make 2 or 3 of these. All right, so write me an inequality for this problem. Take the next 3 or 4 minutes to try to figure it out. Hey, Siri. Hey, Siri. Hey, Siri. Set a timer for 3 minutes, please. Stratford, Washington. Thank you. 3 minutes. Attempt it for me. Bless you. Where do we even start? Somebody try to talk me through where you would even start with this bad boy of a problem. Okay, so we have 16, it says $16.95 each. Let's read the whole problem out. An internet business sells US flags for $16.95 each, plus $2.50 for shipping. Shipping is free, however, on orders that are more than, which one's the symbol for more than? First, second, third, or fourth? 1, 2, 3, or 4? 1, very good. So more than $100. Okay, so let's see. Which correctly shows the number of flags F? So we have to put the variable F. Where do I need to put my variable F in this inequality so that it works? Yeah, so because every flag costs $16.95. So this is the one that shows correctly how many we would have to sell. We have to solve for F to be able to determine how many we have to sell so we don't get charged. But yes, that would be the equation. Yeah. We can solve it to find out if you'd like. Okay. So how would I solve this equation? What would I move first? Yeah, so let's move to 2.5 and let's see. So I'm going to subtract 2.5 from both sides. What's 100 minus 2.5? 97.5. Okay, so we have 1695 is equal to 97.5. So what's the last thing I'd have to do here? Very good. Divide 1695 by both sides. 1695 by both sides. What is 97.5 divided by 16.5? Close enough. Good for me, Mr. Schultz. So we'd have to round up to 6. We'd have to have 6 flags to not get charged the $250 shipping. Very good. Very good, Mr. Schultz. Write that on out. We're going to do one more problem. I'm going to let y'all attempt one more problem. I should write that on out. This is the review of writing equations out. Hey, Ms. Palmer.
I am his pet.
You're good. Welcome. Make sure you cover your nose and sanitize your hands for me. All right, so one last, give you about 30 seconds. Write it on out. Very good, you guys. Very good. All right, so last problem. I'm going to give you a hint, okay? What kind of function is this? Does anybody remember? Very good, it's an exponential function. So please write an exponential function for this problem right here. Can somebody tell me if this is a growth or a decay problem? What'd you say, Aaron? Okay, so yes. A is your initial amount, and this is a growth problem. So, did they give us an initial amount? Where did they start at? Very good, 270,000. That's a lot of freaking bats. All right, so we have 207. Let's call this B of X because we're talking about bats. All right, so we just got our initial amount out of the way. So now we have to multiply it by, is the parentheses for a growth problem going to be greater than or less than 1? Greater than, okay? So when our B is greater than 1, it's growth. So 1 plus, what is the percentage that they give us? 2.9. How do I take 2.9 and turn that into a decimal that I can put on the inside of that parentheses? Does anybody remember? Yeah, I'm going to divide it by 100. So do 2.9 divide by 100. I get 0.029. So 1 plus 0.029 x. Using the scientist's prediction, create an equation that models the population of bats after X years. That is the growth formula for the number of bats that the scientists are studying. for the last, once you get done writing, you have 5 minutes. All right, I want you to take out that blue sheet of paper, and for 5 minutes, we're going to work on our skill builder. All right. Hey, Siri. Set a timer for 5 minutes, please.
Okay.
So this is going to be a little shaky. First day of review, I understand. Let's go ahead and attempt our, take out that blue paper, spend the next 5 minutes attempting to do that work. See if we can remember anything about that topic, SSC.1.1. Watch your eyes. Carson, you need to go to the clinic. Keep your head up, please. Let's get to work. Let's attempt those first couple problems on that blue sheet, please. Read for me. Let's attempt it. I'll put it up on the board so there is no boom, boom. Last one, skill builder for last 5. This is pretty much what the year is going to be like. I mean, it's either I go over them with you or you're forced to read. Last 5 minutes of class on. All the way up. See. Boom, boom. Okay. For the rest